lecture by Dr. Josiah Zayner. We're hosted by the UCLA Executive Cluster Program, obviously the Biotech Cluster, and the Institute for Society and Genetics, our home department. For those of you not in the course, the Biotech and Society Cluster is a year-long interdisciplinary class for first-year students that explores contemporary topics at the intersection of science and society using a case study approach. Dr. Zayner is joining us as part of our Do-It-Yourself Biology unit, where we explore such topics as the democratization of science, regulation and management of risk in biotechnology, and the applications of emerging technologies such as genome editing using CRISPR. So now it's my pleasure to introduce Dr. Josiah Zayner, who has a PhD in biophysics from the University of Chicago. After completing his PhD, Dr. Zayner worked for several years as a research science in the synthetic biology program at NASA. Dr. Zayner is a well-known biohacker, proponent of public participation in science, and critic of the exclusivity of institutional science. He is the founder and CEO of the Odin, a company that sells do-it-yourself biology materials, such as the Iliad Project Kit, designed to allow users to test compounds for antibiotic properties, a kit for CRISPR-mediated bacterial genetic engineering, and a tree frog genetic engineering kit, which I was really interested to see. In addition, Dr. Zayner is well known for conducting a number of experiments on himself, including a microbiome transplant, which was recently documented in a New York Times op-doc titled Gut Hack, and a CRISPR injection aimed at knocking down the muscle growth regulating gene myostatin. Dr. Zayner also brings his expertise in biology and genetic engineering to the art world, where he created the chromophore, an instrument that relies on light, oxygen, and voltage-sensing proteins to generate music, among other interesting projects. So we really hope that you enjoy Dr. Zayner's presentation today, which will be followed by a Q&A period. We'll be walking around with microphones for y'all. And in addition, we'll be hosting a reception after class in the Denev Quad, which is just outside, and there are a few signs leading you out to the quad, where we can all mingle and chat with Dr. Zayner as well. So please join me now in welcoming Dr. Josiah Zayner.
Thank you so much. I'm really excited to come here today. I don't get the chance often to talk with students and people who are younger than me, but I think they're the coolest, just so you know. I'm not looking for any sort of applause or praise, but you guys are awesome. You're so amazing. I love you. The future of human genetic engineering, and this is, can I swear in this class or no? I just want to make sure. Some people, and the problem is when I really start swearing, it can get out of hand, so I'll try to keep it down. I grew up on the south side of Chicago, at times, so you can imagine. But when they asked me to do this talk, it's so crazy because most of you maybe have heard or haven't heard, but just a few days ago, a scientist came forward and claimed that he created the first genetically engineered humans. He modified some embryos and put them in a woman, and she gave birth to these children. And it's so crazy that in the time that I created this title, the future of human genetic engineering, the future is here, and the future just keeps getting closer and closer, faster and faster. And every time I see this stuff that comes out with genetic engineering, it almost scares me a little how fast things are moving. And it scares me, and I'm the guy who's trying to genetically engineer myself, which is saying something. So going into this, I just want to say that I know this stuff is different and scary, but what I'm hoping to get to at the end is that you see it as something that's also amazing and beneficial and can help us out a lot. For me, my story starts in graduate school, and there's basically two things you learn in graduate school. If you're doing molecular biology, genetic engineering, biophysics, that type of stuff. The first is that it doesn't matter what anybody tells you or says. The reason that they're going to graduate school is because they want to genetically engineer humans and or make dragons, right? Let's be honest. That's what we all want to do. You're like, where are the scientists who are trying to make dragons? Why isn't that like a priority? I'm always concerned with that. But the thing is, what ends up happening is you end up studying something like this. Now, this is my paper, so you can make fun of it. The terminal helix modulates like activated conformational changes. What does that even mean? I mean, come on. You end up studying something that's like so almost, I don't want to say insignificant or inconsequential, but it kind of, is a little bit. And it's hard to come to grips with that. It's hard to come to grips for myself with the fact that the science I was doing, like, wasn't the stuff I wanted to do. It wasn't the stuff that I thought would have an impact on society. It wasn't the stuff I just thought would be cool, right? Like, isn't science supposed to be cool? Like, why are we, where are the time machines and lightsabers and invisibility cloaks? Isn't that what science is for, though, right? Like, isn't it? Like, it gave us airplanes. I mean, can you imagine people before they could fly and they were just like, holy shit. When I flew here from San Francisco, I always think that when I'm in an airplane. I'm like, this is insane. I'm in this metal tube 30,000 feet in the air. Like, what's going on here? Right? Science is supposed to bring us that awesome stuff. It's not supposed to bring us the terminal helix. But actually, conformational change. But I get it. I get the way science works, and I get, the way that you have to teach graduate students, and they have to learn to do experiments and level up and get to the next place. But for me, it was just, I became so jaded. The whole publication system and all these different things, and I wanted to do something different. I wanted to create something that was real, that exists in the real world. And to start off with, the only way for me to start to work outside of this academic world was to kind of move into art.
What the protein is actually doing. And I thought, well, maybe I could do that with music.
It happens to be that I was already working on a paper about sonification. Sonification is the process of taking non-musical data and converting it into sound.
You watch Star Trek or Star Wars or something like that, and you see these android robots walking around with human cells and all this stuff. And it's like, well, it's so far in the future, right? First we have to start on this basic level. How do we engineer a protein to interact with these electronics?
Yeah, so I created this musical instrument device that, these proteins I studied during graduate school, what they were is they were kind of like the key you play on piano. Except these keys, they respond quantum mechanically to light. So when you shine light on them, they change color. You can actually measure this change, right? It's pretty easy to measure this change. So that change, it's cyclical, like a string. So you shine light on it, and the protein changes and responds, and then it goes back, just like a string would. So I mapped that to different notes and created this kind of musical instrument. And it was really crazy. It was really funny because I remember I would get home from lab at night and I would go into my room and go to my workbench and I would start working on this building. Some nights I just literally fall asleep on top of it on the workbench. And I remember when I finally finished it, work, I wrote the code that makes this thing run. I built all the electronics. I purified the proteins, all this engineered the proteins, the DNA, all this stuff. And I remember bringing it to my boss in graduate school and I was like, look at this thing I built. Look at this thing. And I played it for him. He was like, yeah, whatever. And I was like, oh my gosh. So heartbroken. But it was amazing because I got invited by MoMA in New York to come play this instrument, which was really crazy. I never imagined that would happen, being a boring scientist. But it really opened my eyes to what else is out there, That academia and this intellectualism and this focusing on these small singular things wasn't my thing. It's other people's thing, but it wasn't my thing, and I wanted to do something else. And so I thought instead of doing a normal postdoc and going and doing more lab, work for publishing papers, maybe I could do something else. So I applied for this fellowship at NASA. I wrote this crazy grant. And let me tell you, when you're writing a grant for NASA, it's really weird because you're like, and I'm going to do this thing because then it will help us live on Mars. And it seems so weird. You're like, am I really writing that? Right? Like, this is going to help us survive in outer space. And it was really awesome. It was really awesome. And they actually funded it. I was like, holy shit, you guys are crazy. I can't believe they're letting somebody like me come work at NASA. But they did. They did. And it was, in the beginning, it was really exciting. It was really, really, really exciting. Because, I'm working at NASA. Everybody wants to work at NASA. It's really cool. But what I learned is that it's just a government agency, right? People think NASA is like separate from the rest of the government because, they post cool pictures on social media and you get to see all these cool things. I don't know if you guys watched the recent Mars landing thing. And they got that little picture with all the dust on it. And I'm like, what is going on? I can't see. I think that's Mars. Is it Mars? No, but they do all these exciting events around these things. But the reality of the truth is that it's really messed up. So, like, first off, there's really no money. And the money you get is only available from, like, March to September. Right? Because after September, they have to spend everything because the budget is going to come back out and it has to be voted on by Congress and all these things. And they want to have all the money spent by then. Right? But usually the budget gets pushed off the vote. Like in the last few years and even before when there was a government shutdown, how the budget gets pushed off way into the future. So it's like January, February, March and stuff like that. And then when the actual money gets dispersed, it's even later. So probably from like September to March, you don't have any money. You're just like sitting there trying to do something with no money. You can, hopefully what people do is they try to buy a bunch of stuff when they have the money so that when it gets time they don't have any money, you can do experiments, but otherwise you couldn't. And trying to get people to work with me, hire on students and other things like that, it was extremely difficult. So I'm sitting here working in this massive lab by myself, all this bureaucracy. They make me fill out a form to fill out a form. And it was just like, oh man, what am I going to do? So it's coming up, my third year there, and my contract was coming up for renewal, and I was like, do I really want to stay here? Is that the thing I want to do? I want to do something cool that I thought I was going to do at NASA. I want to do cool things. I want to make dragons. I want to genetically engineer humans, and that's not going on here. I can barely do, the basic experiments. So I decided to leave. And I remember walking around NASA on my last day, and it's really schematic. Let's start over.
Oh, there we go.
No, there's no
Oh, now there's no sound.
All right, here we go. I'm walking around NASA my last day. Yeah, this is the building I work in, biological science building.
Through the program for the summer.
To say goodbye to somebody,
And I was just in between the videos I'm
looking for people around.
That's just a crowd speaker.
You have to understand, we have this 5-story building, and nobody came into work. I remember one day, there's a fire alarm, and we all go outside, and the fire department shows up, and there's like 10 people outside this 5-floor building, and they're like, is this everybody? And we're like, I think so. Like, looking at each other like, is this everybody? Nobody came to work. My boss came to work once a month. Like, seriously, once a month. They got paid. Right? This is the government. Right? We think it's something else, but it's really not. And that's what's crazy. So, I had to leave. And, that's when I decided to start my own company. So I was just like, fuck it, I'm in Silicon Valley. You know, everybody in Silicon Valley, what they do is they start companies. So I'm just gonna do the same thing, right? Start a company. I'm gonna start a company selling genetic engineering kits to people because, you know what? I think that if people had access to the tools to do genetic engineering, that's what's going to create the dragons. That's what's going to create the, humans with wings and cool stuff like that. It's probably not going to be me. I mean, it might be, but it's more likely to be somebody else. One of you, somebody else out there who, I don't know if you guys know, like, Linux, Android, like the Android operating system on your phone, right? Probably the most used operating system in the world, Linux and Android and things it's based off of. And if I asked you, like, who created this operating system, a lot of people might guess, like, somebody from MIT or Harvard or Stanford or someplace like that. But it wasn't. It was this guy working out of his apartment in Finland named Linus Torvalds. He created the most used operating system of our lifetime from his apartment. If that doesn't blow your mind, I don't know what will. And I'm thinking, genetic engineering, why does it have to be any different? The tools are there that people can use. People can learn to do it. Why can't somebody create the next big thing in their house, in their apartment? And I'd be seriously lying to you if I told you it was easy. It's hard. Starting a company, I don't wish it on your worst enemy. Like, don't try it. It's really hard and difficult because, you're going from paycheck to paycheck, and you're just like, you're prostituting yourself just to like get more money to stay alive. You're just like, everybody buy my product, running around town, trying to sell it to people on the street corner, whatever you can do. But it actually worked. That's the crazy thing. And I think that, I blame a little bit of it on myself, but most I blame on luck. But what ended up happening is we started to be able to create this whole ecosystem of different stuff, like YouTube videos and conferences. We have a conference called Biohack the Planet now up in Oakland, California. And this last year it had, 250, 300 people show up. People who are doing science independently, outside institutions, right? This is a guy, David Ishii, right here. He is a dog breeder in Mississippi, rural Mississippi. He works in an oil refinery during the day, and at night, bringing his dogs, he's taught himself molecular biology, genetic engineering, and he's trying to genetically modify dogs. It's crazy, right? And this guy, he doesn't even have a high school education, right? And he's doing complex biology experiments that graduate students do. It's awesome and amazing that people can do that. And that's where this technology needs to go, right? It's like, you can only keep this stuff in the hands of institutions for so long. If you think about computers, if you think about every great technology, right? You imagine when the printing press first came out, and people were like, idiots, they don't need to read. Why make printing presses? And the same thing with computers, they were like the size of rooms, and they were mostly in universities and big companies, and they were like, nobody needs a computer, that's so stupid. But it totally changed the world when technology is made accessible to people. It changes things, right? Everything that starts to get broken down, all these different walls and barriers, making things accessible, it changes things. And that's when I really started to see, like, man, this is the stuff I really want to explore. Not just by selling this, kits and equipment to people, but myself. Like, how can I explore science on a personal level? How can I explore science on a level that doesn't involve publishing papers, doesn't involve grants and all these other things? So, this was in early 2016. Was it? Yeah, early 2016. So been planning this experiment with a friend of mine. Her name is Heather Dewey Hagberg. she's done a lot of different art. One of her most famous pieces is called Stranger Things, I think it's called. Stranger People, Stranger Persons. Anyway, what she did was she found trash people had thrown out, like cigarette butts and gum, and like sent the DNA off for like sequencing or genotyping, and then tried to recreate portraits of people. She worked with Chelsea Manning when Chelsea Manning was in jail and nobody had seen her for like 80 years. She got some of Chelsea's DNA and recreated a portrait of her. It was really cool. And we were friends and we were talking about this, and I was like, oh man, I got this, really crazy experiment I want to do, and it involves bacteria on our bodies, right? Our bodies are covered in bacteria. There's tons of bacteria inside our gut and inside our bodies. And nowadays they're related to so many different things, but it's really related a lot to gut health. And I have been suffering from gastrointestinal illnesses for, years and years, a long time. And I was like, well, we should do an experiment, to try to transfer bacteria between our bodies or between a healthy donor and myself, and sequence all the DNA inside the body, on the body, and see if we could change the bacterial composition from like unhealthy to healthy bacteria. Unfortunately, that involved eating feces. She dropped out. I don't know if that's the reason. Right, because once the bacteria inside your gut, the only way to get to it is to get it from, poop. And all of it comes out poop. Your poop is just filled with so much bacteria. And so the way they do these fecal transplants is they put poop in capsules and people take it. In the U.S., it's currently outlawed. Get this, poop is a scheduled drug in the U.S. Thanks, Trump, right? It is. So it's crazy that poop is a scheduled drug. So it's illegal for a doctor to prescribe you healthy feces, but that's the only way we know to get healthy bacteria from one gut to another. There have been companies who tried to isolate different species of bacteria and just transplant those, but it didn't work. The only way we know is to take poop pills. So I decided to do this crazy experiment, and I remember I was talking to my friends who were documentary filmmakers. I think it was at a bar. This is the story. It was at a bar. There was some biotech conference. There was free drinks, so I went, and I was heckling in the back. I think I was booing. I was like, boo! Literally booing. And they were like, who's this guy? And we got to talking to their documentary filmmakers, and I told them about this project. They were like, we want to document it. And this is before anybody ever recorded me, and I was like, okay, let's go for it. And it came about as this movie, Gut Hack. And here's a short segment on it. I don't know if you all heard about it. Well, it says you cannot play it. Oh well. You can watch it online. So it was the New York Times op doc. It was on the New York Times website. You can check it out there. It's only like 12 minutes long, but it's really entertaining. It did an amazing job. I couldn't imagine anybody doing such a good job with it. But nobody had ever done this experiment before and done the sequencing and tested and looked at the health of the person after and all these other things. And I did the experiment, and the experiment actually worked. Spent thousands of dollars, paid for all this DNA sequencing, taught myself how to analyze it, had third party analyze it just to make sure I wasn't messing anything up. And this experiment actually worked. And it can't work for everybody. I'm not saying it would work for everybody. That's not what I'm saying. I'm not encouraging people to do the same experiment I did. But for me, it worked, and it actually helped. I dare say, healed me or cured me. Cured, I don't think is a very few things you can actually be cured from. But I don't suffer from any of those gastrointestinal illnesses I suffer to this day. It was terrible. There were some times I was going to the bathroom 10 times a day. It was just terrible. right? And it was just taking science into my own hands. We knew there was some studies that we knew the bacteria in our guts were responsible for gastrointestinal things. And there have been a long history of people doing fecal transplants to try to cure stomach issues, dating way back to like, 4,000 BC and crazy stuff. But like doctors, and they're looking, and now in the past year or two, there have been a lot of studies testing like whether people with IBD and IBS, whether these fecal transplants happen. And I hope that soon that doctors in the US are allowed to actually prescribe these things to people. And after that, and after starting my company and all this stuff, I just started getting lots of emails from people who are really sick, and that's the saddest thing. I wish I could talk to somebody, a bioethicist, Scott Gottlieb, the FDA administrator, and just be like, yo man, there's all these people who are suffering and dying. I get a ton of emails, and if they're emailing me, they're really desperate. And they're asking me to try to help them, like, man, you know a lot about the science and genetic engineering stuff, can you help me? And I started to get really involved with these people who had lung cancer, and incurable lung cancer, right? It's terrible, never smokers, people who just had lung cancer, and they were looking for genetic engineering or other ways to help themselves, and I was like, look, genetic engineering is probably not a good thing to do with lung cancer, it's probably not going to help save you. But they found some studies on immunotherapy. Now, immunotherapy is this really cool, crazy new technology right now. What you do is you can find small differences in the cancer compared to your normal cells. And what you can do is you can excite your immune system to attack the cancer because of those small differences and not attack your normal cells. So it's personalized. It's personalized to every single person, right? And even people have gone down to predicting like different immune types of people. So they call it HLA type and all these different things. But there was a study that came out of China, I think, about using immunotherapy peptide to target an EGFR mutated cancer. And they wanted to know how to create this peptide. These lung cancer patients wanted to create it themselves, to try to treat themselves, because everybody else just left them to die, which is crazy. And, I didn't encourage them to do any of this stuff, but I showed them ways they can order clinical grade, peptides, right? This stuff, this cutting edge science is starting to be so reduced in cost and technical abilities that like somebody can go and order a cutting edge cancer treatment online, create a step-by-step guide to do it, and try and treat themselves with it. And some people have. We don't know the results. It's not a clinical trial. It's people who are dying who are trying to help themselves. And maybe there's absolutely no chance that this will work. Or maybe it's so tiny and insignificant that it doesn't even matter. But to them it matters. To them it matters. And that mattered to me. And this is science, right? These people who have no background, no PhD, no nothing, they're the ones researching this stuff. They're the ones studying this stuff. I never met people who know more about physiology, cancer, lung cancer than these people. It was insane the wealth of knowledge they had. Because they can read the same papers all the academic scientists can, right? They can study all the same things. So can you. There's nothing holding you back. And it's crazy because the gene therapy and genetic engineering, these things that cost thousands of dollars, companies are charging millions. Millions. Right? Could you imagine if somebody told you that you have a disease and they could cure you of it, but it cost you $1 million? Well, what would you do? Like, that's crazy. $1 million. Most insurance companies won't pay for it. So nothing. It doesn't matter who you're looking to for help. They're not going to pay for it. And not only that, Glybera, which was a gene therapy for lipoprotein lipase deficiency, a disease that people have, a genetic disease, they just stopped making it. This gene therapy can be made for less than $5,000, clinical grade. They charge $1 million for it, and then they just stop making it. So all people who have this disease never have access to this drug. What you could do is you go to the documents that they filed with the European Medical Agency and other places. He could reverse engineer the DNA sequence that they used to create this drug. You can find the protocols that they used in their, FDA and other applications. The exact treatment they used to cure people of this disease. That's crazy. Pretty intense right there. And so, that's what I found it was I think this is what I want to do. I want to try out human genetic engineering. I want to see how this stuff works. And, I can read as much as I want about it, but that's no replacement for clinical, doing an experiment on human tissue, taking tissue samples, measuring different levels and stuff in the tissue. I wanted to be able to do that. I couldn't, ethically experiment on anybody else, so I had to experiment on myself. Motherfucker. It was a year and a half just doing experiments on myself, testing a bunch of different things, how to get DNA into the body, all these different techniques that people use, doing tissue biopsies. That's what you saw at the end. Oh my gosh, it's so terrible. They have this little round circular thing that's like a giant, I don't even know what to describe it. You just push it into the skin and it chops out a piece of skin. And it's just ugh, it's terrible. I did that. I got little holes on my arm to extract the tissue so then I could do, analysis on it, analysis on the DNA sequences in there and other things. And I was successful, which was crazy. I got this gene from jellyfish into my cells, so I think I'm the first human jellyfish hybrid. Yeah. I got that going for me. I need to update my Wikipedia page, I think. But it opened up so many possibilities, right? Understanding how this technology worked, and it sucks that I had to experiment on myself. It's not something you want to do. No sane person. No sane person wants to do that stuff, right? That's just crazy. But it did. And then there's new technology that came out that was CRISPR. And they're saying how it could save so many lives and help so many people, but next year we'll test in humans, next year we'll test in humans, next year we'll test in humans. I was like, fuck that. I know how to make this stuff, I know how to do this stuff. Why don't we test in humans right now? What are we waiting for? There are millions of people dying of genetic diseases that are getting no help just because you're waiting a year, you're waiting, for the FDA to approve something to be safe and test this stuff. So crazy to me was shit, I'm just gonna inject myself in front of a bunch of people and just be like, what's up now? And that's what I did. So I was at this conference and I gave a talk on how to genetically engineer a human. Because I was like, people think this stuff is crazy and taboo and it's not possible, but it is. You can actually, anybody here could do it pretty easily. And so I was like, let me tell you how to actually do this thing. And when I got near to the end of the talk, somebody was like, well, if it's so easy, why don't you do it? And I was like, fine, I will. Luckily for me, I thought somebody was going to ask that question, so I kept the syringe with me and some, DNA to inject in myself, and talk about going over the top. But yeah, it was crazy, but it was also great You know, it's like people don't understand how accessible this technology is, and it's becoming. It's that easy. A couple $100. You could create a gene therapy for yourself, for other human beings. And I got, tons of backlash after that. The FDA, which I think is their fastest regulatory thing I've ever seen, in like less than a month, they immediately came out with new regulations regarding CRISPR gene editing in humans, and they're aware of gene therapy products intended for self-administration and do-it-yourself kits produced by gene therapy. They're basically referring to me, and I was like, holy crap. A little bit of me was proud, but it's also like, damn, it's going to be a lot harder to get this stuff going than I thought. That's all right. This is supposed to be a really scary clip from Gattaca, but we won't play right now, but that's okay.
They've all seen it.
Genetic engineering humans is scary. It is. It's scary to a lot of people and a lot of things. The first question I always get, that was really cool. I sat down at lunch with you guys. Whenever I get interviewed by somebody, they're always like, what about eugenics and Nazis? People are scared of this stuff, and it's really scary to people. Human genetic engineering, right? There's some people who, it wasn't human genetic engineering, but eugenics and things like that people were trying to use under a bad name. And that's terrible. But the truth is that human genetic engineering isn't a bad thing, right? Because if you look at everybody in this room, everybody pretty much in the world, not just this room, like, you didn't have a choice in the genes you have, right? Whether you're tall or short, skinny or fat, whether you got a snaggletooth like me, you didn't have a choice. You didn't. Your parents, in most cases, really didn't have a choice either. Nobody had a choice, right? No choice at all. What if you did have a choice, though? What if you had genetic freedom? What if you could choose the different things that you wanted to do? Right? What if you could choose if you wanted to be pink or red or have wings? But we already choose so many things about us. Like, you look at yourself. I have different colored hair. I have piercings, tattoos, the clothes I wear. We choose everything about it. Everything about it. Whether we exercise or don't exercise or all these things. But we can't choose our genetics. The crazy thing is, now we can. Genetic engineering is that accessible and available, even for adults in some cases. There's a possibility you can choose your genetics. And to me, that's just like amazing and mind-blowing, right? The first time in human history, every human that existed before this, no choice. Now, we're getting to the place where we have a choice. To me, that's not eugenics, that's freedom. That's amazing, and I think it's going to create amazing and beautiful things. And maybe that's just me. And then, just a few days ago, earth-shattering news. A scientist, and I hate that they write Chinese scientists. It's terrible. It's like they're trying to say something with that word. It's a scientist, not a Chinese scientist. Scientists created babies using CRISPR gene editing technology. The first ever genetically modified humans were born. He edited the embryo, he implanted them in a woman, and she gave birth. Now, this is all I wanted to talk about. That everybody, every person I see when I'm in the airport, and the guy's like patting me down, I'm like, genetically modified babies, man. Oh my God. It's the craziest thing. Like, Literally, this moment in history, no human before this time has been born, has been genetically modified. No human being, right? You're talking trillions and trillions and trillions of humans. None of them. I mean, crazy. Crazy. And it's interesting because if you actually look, they've done surveys and see, and a lot of people are supportive of genetic engineering when it comes to diseases. A lot of people. And nobody expected this. This wasn't a researcher in a university. It wasn't a researcher in a company. It was some guy who just did it. He paid for it himself, he said. More facts are still coming out. He said he paid for it himself. He found some parents through HIV support groups, and they wanted to have a child that was immune to HIV. There are well-known mutations that are naturally occurring that can make people immune to HIV. Mutations in this gene called CCR5. We made mutations in the gene, and they made the kids. It's a lot more complex than that. They did a lot more studies of the genetics and a lot more details, but it was really legit that this guy just did. Twitter's the butthole of the internet, let's be honest. But if you look at the response that people have, this is fucking vile, and I don't say that lightly. Disappointed to read this. If true, this experiment is monstrous, premature, dangerous, and irresponsible. All scientists and institutions, all they can think about is what they think is a terrible choice by a person. Including consenting adults, parents who wanted their child to be this way. Highly educated, they understood what was going on, and they chose this. And people say they're monstrous and vile and terrible people who want a child that doesn't have the risk of having, serious diseases. Yeah, it's crazy. Because all I can still think about is just like how monumental this is. Just like, oh my gosh, this is crazy. And this guy did it, and he did it so well. And it works so well, and it's so good, and all people want to say is monstrous and vile. And there's so many opinions. You can have whatever opinion, you're totally allowed to have that. But to me, this is a shifting point in humanity, right? Human beings are going to be different species. Ever since Homo erectus became Homo sapien, we've hit like a genetic bottleneck. Homo sapiens have been the dominant species on Earth, the only Homo, right? It's childish. You shouldn't laugh at that. But now it's changed. It's changed, right? Homo sapien, there's a new species now. Think about that. Wow. Yikes. And all I can think about still. Not long. All I can think about now is I get these emails from everybody all the time. This guy Matt, he contacted me. He had serious cancer, and we kind of became friends. I told him I can't really do anything for him. Like, man, I can't really help you. I can't really try to treat you. The regulations in the U.S., the liability, they'll throw me in jail, right? I want to be able to help you, and I wish I could. And this is yesterday. And this is really sad. It's even hard to read. And he said, hey guys, been back to the Mayo Hospital in Phoenix. I'm off these last 2 weeks. They go into surgery tomorrow. Regardless, bottom line is that cancer's exploded. My pancreas, gallbladder, liver. Things aren't good. I'm too far gone for any treatments now. Any chemo will kill me faster than just managing the pain to death. So it's hard to say how long I've got, but please know it's been one hell of a good ride. Thanks for letting me tag along. And that's all I can think about and see. While people say the people who are trying to push this technology forward are monsters and vile, this is all I see. people like Matt, people who email me, who didn't have a chance. Nobody's given them a fighting chance. Nobody fucking gave them a fighting chance. You got to use chemo, which is the shittiest drug. You know how chemo works? It stops cells from replicating. You're literally killing your body. Your cells cannot replicate anymore, right? That's why your hair falls out and your stomach lining. You're stopping all your cells from replicating. Sometimes that kills cancer. It does work sometimes, but you're literally killing your body to kill the cancer. It's so terrible. That's all we've got? In 2018, that's all we've got? Right? How is that possible? You know, I live up in the Bay Area. We've all been suffering from these fires and shit lately, right? Terrible smoke and everything like that. But, you know, the fire comes in and just wipes out all the underbrush, and from the underbrush, that's when the new trees and plants grow, right? And sometimes I'm just like, fuck it all, let's bring down the FDA and the whole fucking government. Destroy it and bring it up, you know, just bring up something new. Maybe that's the way to go. I don't know. I'm no political or economic expert. But I also think there's another way, and that way is if everybody here, if everybody in their apartments is learning about genetic engineering and DNA and knows how to use it, if everybody here could code the DNA sequence for Glivira, a drug that could treat disease, how long do you think the FDA would have no choice but just be like, fuck it, we can't do anything? These people are curing people. Like, what am I going to do? You know? As much as I hate it, this person got cured. And I think that's how you can contribute. That's how we all can contribute. So, with that, I'm done. Thank you.
So, we've got,
That was a little intense for me.
so now we've, going,
We have time for questions.
thank you.
So if anyone can raise their hand, we'll run up and give you a microphone and
Yeah.
ask a question for Dr. Zayner. Don't be shy.
Come on,
Don't be
post it.
shy, come on. I know you got questions.
Yeah, up in the back, yeah.
Hi.
Sorry.
Hi. Have you seen like a spike in sales since they've released the CRISPR baby thing?
Oh, it's an interesting question. It's hard to tell because people buy a lot of gifts for the holidays. So it's true. It's like a Christmas gift. People buy genetic engineering gifts for their friends. And so it's really hard to tell. There might have been, but it's extremely hard to tell. I think there might be. I think a lot of people are interested in the technology.
So you're talking about the future, and like, what do you envision the future to be with gene editing?
Oh, do you want my vision or what it should be?
I want your vision of what you think that can happen with gene editing, and what do you envision that doing? Like, do you just expect like everyone, like if people can pick their own genes or parents can pick their own genes, do you think it's going to be more like a beauty thing and everyone's going to pick their kids so exactly the same, like the perfect supermodel or things like that? Or are you envisioning it more in a way of health and things like that?
Yeah, no, I think it's super cool. See, people focus on these things like outward appearance and things like that, but I think that stuff is probably gonna eventually go away to a certain extent because you think like, if you could modify yourself to be good at a task, right? Let's say you want to be an astronaut, right? Even right now, astronauts have to be certain heights and weights and all these different things, right? That's mostly because that's how all the equipment and stuff is built in the space shuttles and space stations. But there are definitely like height restrictions. But in outer space, it's better to be shorter and stockier for center of gravity and all these other things and survive G-forces, right? Human beings aren't meant to go to outer space. Not even a little. Like, we evolved on Earth. But you can imagine somebody being genetically modified or genetically modifying themselves to be like an amazing astronaut, right? Or something else. Maybe, having an extra arm would be really useful. I'm not saying we could do that right now, right? But you have to imagine that, like, biological things are understandable. If you could see it in another organism, it's doable. It's just a matter of time, right? It's not impossible. It's a matter of time. And so, yeah, I think it'll start to branch out to stuff like that. At first, it's going to be, what you see right now, it's a lot of the people who are more risk tolerant. So it'll probably be for crazier things, like extra limbs or other stuff. You should see the experiments they've done on mice. Oh my gosh. No joke, this is the strangest thing I saw the other day. So my PhD, I worked on these light-activated proteins. You shine light, and in plants they make them move and do stuff. And people have co-opted them and put them in a lot of different organisms. And I saw this study, I kid you not, they attached these light-activated proteins to another protein, and they genetically engineer a mouse. When you shine light on it, it gets a boner orgasm. This is a scientific paper. I'm not even joking. This is a science. And it's terrible. They have pictures of the mouse boners in the paper. And it's like, this is a published scientific paper. So, there's some crazy stuff waiting to happen.
Have you ever received word of something wrong happening with one of the kits you sold? And if so, to what extent would you feel responsible?
Yeah, that's a really tough question, right? Because actually, when I did this injection on myself, it created, I don't know if they were inspired by me. They didn't say like I was inspired by Josiah. But like after I did it, a couple of other injections followed closely after by other people that I really never heard of who didn't have any training in this stuff. And whether it was due to me or not, it was really interesting because it was hard, because it's something that I did feel a little bit of responsibility for, because like the experiments I did, you saw in the one video, but it didn't even go close to the depth that like I was working on this stuff for like a year, testing a lot of different stuff, taking tissue biopsies and testing all these things. And then some guys just go and jab themselves with a needle with DNA, and they're like, yeah. I did feel responsible, because I was like, how should it move forward? But then, if you think about it, a lot of these technologies you can't stop people from using it or using it stupidly, right? And that sucks, but it's just part of life. And the first people who are probably going to use risky technologies are people who are more risk tolerant and a little bit more, like, I don't want to say crazy, but are just more like, go ahead and do stuff. And I have to try to distance myself from that, because I know that was never my intent. I never preached for, other people to go inject themselves. I might sound pretty close to it sometimes, so I'll be honest. But yeah, no, it's hard. I deal with it all the time. And I would feel terrible if somebody got injured or died or something like that. That's why I don't work with anybody to help them do it, because I couldn't bear if something went wrong.
I'm not exactly against this type of thing. I think it's weird and I don't understand it, but you said that for the first time ever, people have a choice. But what happens when, again, I'm not against it, but if a parent decides to have too much of a choice over a child, and then the child doesn't like the choice that their parent made?
With genetic engineering or without?
well, you don't have a choice really, like you said, without genetic engineering, but with genetic engineering.
No, I mean, in general, though, it's interesting. That's one of the hardest questions, right? Because, like, when a parent is choosing traits for their child, they're making a choice for their child, right? And they're removing a choice that possibly the children could make. It's hard, because, like, a parent, they choose everything for the child, right? So, like, they get genetic testing usually to see if the child has any genetic abnormalities. They choose whether to keep the child or not based on that. Some people, they raise the child a certain way, feed it certain food, send it to certain schools, educate it, train it a certain way. And they give the child basically, no choice for a lot of things until they get old enough to make choices by themselves. So it's like, how much do those differ? And I think each person is going to have their point and their limit and stuff like that. But it's like, to me, myself, if I had a choice to make my child, be immune to diseases, I mean, I imagine for a large majority of people, somebody said, hey, when you go to the hospital, they say, if you want to pay $10,000 extra, we'll make your child immune to X, Y, Z disease. Make sure they don't have this stuff, like we already do with, testing of the mother's blood. I think most people would take it. I would. They came to enhancements. I think a lot of people would take it also, right? If somebody told you for another $10,000, you could make sure your child was athletic, strong, good muscular endurance, I think most people would take it, And I don't know where to draw the line. Can you draw the line, right? If this guy did this experiment, without anybody knowing virtually in the rest of the world, maybe people in China, but, most people, no scientists really knew about this. Where do you think that's going to go? Like, people are going to do it anyway. Can you stop them? Maybe, I think, for me, it's not about stopping people, because look at the war on drugs. Like, drugs won, we lost. When you make wars on things, like, they're going to win out. People are going to do it. You can't stop technology. You can't stop progress. You can try your hardest, but you can't stop it. And so maybe if we focus on how we make this technology available to everybody, so that this divide between, class and wealth isn't there, I think that's the thing we should focus on. Not, like what can and can't do, because people are going to do everything eventually. But like what we can't control right now or in the future is like if it costs $1 million, like Libera, right? If companies want to charge $1 million for it, you can't stop that. So. Yeah, right here.
Okay, cool. So, to some extent, I mean...
Oh man, did you write down questions? This is going to be tough.
No. So to some extent, like whether you like it or not, you are sort of the face of this like DIY bio revolution. And you had the clip from Gattaca, and like Black Mirror is a thing. There are so many modern pieces of media that are really just trying to inject that fear factor into bioengineering and sort of the future of science in general. So what strategies do you employ as the sort of face of the movement to overcome that fear factor and kind of pacify people in their panic as they see this stuff on TV?
One, I don't necessarily dislike the fear, right? Because if I tell everybody, hey, there's something up behind this podium, and it's so dangerous for you to see, it's so dangerous, and I walk out of the room, everybody's probably going to go up and look back behind me, right? Somebody is. You're like, what is it? Could you go? Check it out. Fear, is almost like a mixture of excitement, right? Fear is excitement and being scared and all these things. But I also I don't fight against the fear, but I also counter it with just like completely the opposite, right? I try to make science entertaining. I try to make it fun. I try to make it, exciting. I try to do complete stuff other people aren't doing, right? It's like, let's be honest, nobody watched Cosmos all the way through. We love you, Neil deGrasse Tyson, but like, nobody, it's boring. Science doesn't have to be boring. It doesn't have to be that way, right? And, that's at least my goal. Show people science can be entertaining.
Genetic engineering, can you hear me?
Yeah.
Yeah, genetic engineering, like any technology, is arguably a tool that can be used to do good as well as harm. And I get your argument about how people are probably going to do it anyway, like how you cited the war drugs. But fact of the matter is, there are certainly steps we can take to mitigate the harm people do with such technology. So what kind of regulatory framework, if any, do you propose we put in place to make sure that it's good being done rather than not?
So he asked, like genetic engineering can be used both for good and bad, right? It can be used to create like harmful diseases and stuff like that. It's really interesting. My big argument is that like genetic engineering doesn't have intent, right? Like if you do genetic engineering, it doesn't have any inherent intent. It's a human being that gives it intent. If a human being can turn, as we all know, like a pressure cooker into a bomb, or a kitchen knife into a weapon. It's a human being that requires intent. And when human beings do something bad, it's always illegal, it's always banned, it's always out. Now, that's not going to stop people from doing it. But I think about it kind of like automobiles and cars. It's really hard right now to get in regulation and help people because there's not a lot of people using it. But the first people who used cars, like, there were no rules. And then they were like, hey, maybe we should put in stop signs so people don't crash into each other all the time. People were like, okay, that's reasonable. They're like, maybe we should put in guardrails because then people will like go off the side of roads and stuff. And there might be some crazy libertarians out there who are like down with stop signs and guardrails. Government shouldn't have to tell us how to drive. But in general, nobody's going to argue against those things, right? I think we can have certain common sense regulations that don't inhibit innovation and progress, but put guardrails out there for people so that they don't hurt themselves.
Do you think harm is a byproduct of progress, and how much is acceptable?
Yeah, no, it's a really good question, because if we go back to automobiles, there's 1 million or more people who die every year in automobile accidents. And ask any person, would you give up, should we outlaw and ban, vehicles, automobiles, cars? Nobody's going to say yes. Because it's such an amazing innovation. It allows us to travel places faster than we could possibly otherwise. It's such an amazing innovation in humanity. Millions of people die because of it. And we're okay with that. We sacrifice them to the automobile gods, right? It is. It's like a modern altar. It's really weird. And there's other things, where people die and from a gene therapy or something like that and freak out. And it's when people become comfortable with it, right? When people become comfortable with the technology, I think that's the thing. When it becomes commonplace, it's like people are less, I don't want to say they care less about the deaths, but they do. And genetic engineering technology is the most powerful technology, right? Here's the thing. You're programming a computer, it's digital. When you're programming with DNA, it's self-replicating, self-organizing matter. Think about that, right? Self-replicating, self-organizing matter, and you could program that to do things. That's crazy. The most advanced technology we know of, probably put by an alien. I said it first.
If the FDA does legalize the gene editing kits, do you think people will start applying for patents on their gene editing techniques, and would that be an obstacle?
Yeah, people already have with a lot of this stuff, which is really terrible. as CRISPR technology patents, it's a naturally occurring system in bacteria, but people apply for patents for its use. Which I think is terrible, because if it really can save humanity and everything, like, how can you patent that technology? People definitely will. I mean, we live in a capitalistic world, whether we like it or not. And I hope people wouldn't, and maybe people in the future won't, but it doesn't look like that way right now. All right.
Any more questions? One more over here? Yeah.
Based on your knowledge of CRISPR, like with the new CRISPR babies being born, will their like genetic information be passed down to their offspring so they'll also be immune to HIV?
Yeah, but not completely, right? Unless their partner is also HIV resistant. So generally what will happen, right, is they'll pass down generally like one copy of the gene. So you have two sets of chromosomes, right? So one set from, yeah, so it will.
I didn't think about that.
Yeah, no, they will, and they possibly could. The thing is that it's really hard to get stuff to, people are worried about stuff passing down through generations, but it's really hard to get stuff to spread in humans because of the time that it takes to like have kids, and for those kids to have kids is really slow. And usually anything can be corrected, right? So like if this person didn't want to have her kids have the same mutation, she could do the same procedure and change it back. So it's you know, I don't think it's as difficult to get out of the situation as people imagine.
All right, well, thank you so much. Let's give Dr. Zayner a round of applause.